All right, I'll share my screen. All right, well, thank you, Heather, and the rest of the InnovATEBIO community for this opportunity to speak today on a topic that is, I hope, very interesting to everyone who signed up. That's why you're here, right? I'll just take a moment to introduce myself, but today's talk I titled it, How I Learned to Stop Worrying and Love Biohacking, At-Home Biotech Teaching for a Pandemic Era, a reference to the Stanley Kubrick film, Dr. Strangelove, of course, but referencing also the controversy that I'll get to later in the talk about biohacking that some of you may be aware of. I teach at Laney College in Oakland, California. I've been teaching biomanufacturing since 2012. Our program has a stackable certificate and AS degree structure. So we have 2 certificates that lead into an AS degree in biomanufacturing. And then we have a transfer option for students in our area who want to pursue a bachelor's degree. They can go to Solana Community College, which is about 45, 50 minutes away without traffic, of course, east of us to learn biomanufacturing and bioprocess at an amazing facility that Jim DeClos and his colleagues run out there in Vacaville next to Genentech. Our program has traditionally focused on biomanufacturing in the sense of, preparing students for careers in pharma, biopharma, and biotech services type companies that provide, oligo synthesis, what have you, reagents, manufacturing, medical device, things like that. In the last, I'd say 5 years, we've had a big shift in our local industry where there has been a huge explosion of startups in food technology. So a lot of you may be aware of companies like Impossible Burger or Perfect Day or Geltor or Bolt Threads. That's materials, but not food, but the last one. But these are all companies that use synthetic biology to generate new protein products mainly that are transforming our food system and how materials are made. So I'd say about 60% now of the students that we get hired out of our program aren't going into pharma or pharma companies, even though they're still here. We've got a lot of them, like Bayer and Genentech and BioMarin. Most of the 60% I'm talking about, they go to these synthetic biology companies that are doing food tech or material tech. So part of what I hope to explain here is part of the justification for what I did this semester. It was a total departure of our normal curriculum. We're doing a lot more molecular biology, but we're also, we've just submitted a grant to NSF ATE for creation of a new synthetic biology certificate program to meet our industry needs. So maybe I should have waited to do this experiment with at-home biotech until the grant was running so I could look really good, but there's not enough time to do that sort of thing. You got to just go where where the need is, right? And my students, as we all know, our students crave hands-on experience. And how do you do that when we're locked out of our labs? We're in California, like I'm sure the rest of a lot of the other places around that you all represent. We've been out of our labs since March 13th or 11th, 13th, somewhere in there. That picture you see there in the background is 2 of my TAs. I'll talk about them in a moment, but we were in our lab over the summer prepping the kits that we ended up using. And I'll talk about those kits mainly. That's the focus of today's talk. So, and please, yeah, as Heather said, please interrupt me with any questions. I'd prefer this to be an interactive talk as much as possible. So please, type your questions into the chat or however else you want to ask your question. Okay, so the why. Why did I pursue at-home biotech kits? As I said earlier, when we were locked out of the lab in March, we had to, like everyone, do online teaching. It wasn't going very well. Did the best we could with simulations and online material that I was able to kind of scrounge together. Actually, I put a plug in for InnovATEBIO. The webinar series InnovATEBIO ran in the spring was amazing. It provided a lot of resources that I didn't know about. So I'm sure some of you were on those calls, those were incredible. But we all know that hands-on, there's no replacement for it. So The main justification was like, what, our students, we always look to serve our students and put them first. So what do they need in order to work in this industry? They need hands-on skills. Our programs require it. We know too, I mean, we all know this, it's hands-on is just exciting and engaging. It's our student. I sometimes think though that, our students become a little bit of action junkies, at least I don't know if like, in other words, if you're doing something that isn't hands-on, they get less engaged by, because they're used to the action of hands-on. But even when it's very simple exercises like pouring plates, making solutions, those are way more engaging than even a simulation about it. So if they're doing even just mixing things at home, I know that some of my colleagues in the Bay Area are doing at-home biotech using a lot of kitchen supplies, and they've written up labs or kind of adopted materials that allows students to use common things in their kitchen to do biotech or simulate biotech. Another reason is, we had grant money through Strong Workforce that, we have timelines on spending. So we budget for all this, consumable costs. We weren't using it. So this is a great way to use it, right? We found a vendor that provides these amazing kits, and I'll talk about that more. And then the other thing is, I mentioned colleagues that are making their own kits from scratch. That's amazing. I went for convenience. I wanted something kind of ready-made, and it was right in my back door. So that was another justification. And the final one I just say, which I mentioned earlier, is that this pivot, if you will, for this semester allowed me to explore more of our new curriculum that we're developing for our certificate in synthetic biology. So that was another justification for me to do this. I just want to point out the picture there at the bottom. That's us about 2 weeks before the lockdown. I know Ying Su is here, and Baybec she represents Baybec, the Bay Area Bioscience Education Consortium. We pour a lot of plates for local high schools. That's just a small sampling there of the plates that we pour each semester and each year. And those are selective media plates that go out to local high schools for teachers that need them, right? Because they don't have the time or the funds to buy them or make them themselves. So we provide those, and we do that through Baybec. All right. So about a year ago, I met the CEO of a local company called the Odin. His name's Josiah Zahner. His company is located in West Oakland, which is a stone's throw from where Laney College is. It takes about 10 minutes to drive to. And since I met him, we started talking about ways we could partner. And one of the first ways we were able to partner is that he hired some of my students. He has a lot of part-time lab assistants. And so I should probably say first what the Odin does. The Odin is a biohacker supply company. They make kits and reagents and materials for people to do, quote, biohacking at home. And so I guess you could just boil down biohacking as like community science, citizen science, garage science. The ethos or the kind of like driving feeling of it, if you will, is like in the 70s when the tech companies were starting in people's garage. That's the feeling of the biohacker community, is like we're starting a new revolution of distributed, open biotech that anyone can access. So I had Josiah Zahner come and speak to my students. And if you want to look at a talk that he gave, it's on our YouTube channel. I've got it linked there, and I guess we can share these slides later. But the kits that he's already made they're geared towards people using the materials in their home. So the labs that he designed the kits for are kitchens, garages, sheds. So whatever's like, he does sell a lot of equipment through it, but obviously I didn't need to buy that because I have a good amount in my lab at Laney College. But because it's written for a home environment, like it's much easier to adapt than say like a Biorad kit, which is another local company, but they generally make their kits, for a well-furnished and equipped lab, like a traditional lab. So the other thing that the Odin brought to our program, although I'll talk about some controversial aspects of it in a moment, but it brought some notoriety, and perhaps, I hope not infamy, but at least notoriety. I mean, Josiah Zahner and the Odin is internationally known as the biohacker supply company. He's sort of the poster person for the biohacker movement worldwide, and I feel lucky that we have him in our backyard, and he's a partner to our program. And more than that, we were just talking about this before the call started. There are biohacker, let's say biohacker bio community labs all throughout the country. These are just community citizen science labs where people get together and do biotech, and they often require no experience. You just dive right in, and this is sort of going back to that kind of rugged, can-do aspect of biohacking. In the Bay Area, we have several of these biohacking labs. You could say it started in the Bay Area, I guess, but there's debate over that. Counterculture is local to us. It's an Oakland-based biohacker lab. BioCurious is in the South Bay. There's one more, I think, on the peninsula. I forget the name of, but the biohacking community is really strong in our area. And I get a lot of students that come from that background. They actually start at a biohacker lab. They find out about our program, and then they come over to us. And what we do is we provide a lot more rigor, right? Because we're not, if you've ever been to a biohacker lab, the ones I've been to, most of them, well, not the two that I've been to, I should say, they are, it's sort of like the Wild West, right? I mean, you're lucky if you've got a line on the ground that indicates where, you shouldn't bring food into this area or not, like that. It's kind of, yeah. But yeah, so they come to us, and we give them like more traditional training that gets them up to speed. So, okay, so our local partner, the Odin, Josiah Zahner, if you just do a Google News search about Josiah Zahner, you'll come up with some. I thought I'd just hit this up front because I don't know how many of you have heard of the CEO of the Odin, Josiah Zahner, but he is a controversial figure in biotech. And so if you do this, you'll find out. I'm just doing it for you. These are some recent headlines the last 3 or 4 years, I guess you could say. And he has done things that are provocative, right? Including probably the most provocative being self-injection of a CRISPR therapy that he made in 2017. He did that on the stage at SymBioBeta. Later regretted it, but he did it, and that made him, well, as infamous or famous as he is now. And then most recently creating and self-testing a COVID vaccine plasmid. And so I only bring this up, I'm not endorsing this, like I don't endorse self-experimentation, but as part of the partnership, when we post something about using his kits or something, it brings more notoriety to our program, just more, I guess, profile, maybe, if anything. But you can also follow up with the Netflix documentary there too, which features him, called Unnatural Selection. I'll just leave it there. But I did realize, recently that some people aren't aware. This is more of a local news story, right? So it's not widely known across the country, but since some people are exploring their kits now because of all the need for at-home biotech in all our programs, you might want to know what you're getting into, just in case, who you're endorsing or indirectly endorsing by spending money with them, perhaps. I just make it explicit with my students, like, hey, look, we're using their kits, but I don't endorse everything he does. The kits are good, they work. I'll show you results from that very soon, but it's something that I don't really, concern myself with, is self-experimentation. My students know that too. So, okay, so first thing we did is we adopted or tried out a kit called Genetic Engineering 101, and I'm not trying to sell people on using his kits. This is what we did, right? There's plenty of other kits you can use. I've heard of people using Biorad kits at home and stuff too, but we used their Genetic Engineering 101 kit, and I was dubious myself whether or not everything would work, so we tested it over the summer. I had 2 TAs pictured here, Jenny on the left and Paul on the right, that were helping me out, plus a third person that's not pictured. He was testing it actually in the lab. So we had 2 people at their home doing the kit and 1 person in lab. The kit is 8 weeks of curriculum. And when you remove the cost of equipment and things like that, I'll go over this in the upcoming slide, it actually is very affordable, but you're getting 8 weeks of curriculum out of it. And we're just right now finishing week 5, 6 of the curriculum. I started a little bit late with my class just to make sure enrollments were settled down. But we're almost at the end of the first kit, which is 8 weeks of curriculum. And so here, they took it home, they tested it, they brought all the equipment. We just made notes, and we were making sure that everything worked. There weren't any issues. If anything came up, we could troubleshoot it together. We modified some of the protocols to put in notes that for explanatory notes for students that are brand new, right? This, you might want to try it this way, or, one thing that came up was it didn't explicitly say anywhere that what your water source should be. I think it maybe mentioned once in the protocols, maybe, use distilled water. It wasn't very, it didn't make it very explicit. And we had an experience really early on where one of the people testing the kit had used tap water to make their agar plates, and you're just boiling it in the microwave. So it wasn't enough to sterilize it. So they had a lot of contamination. So, okay, now we know. Tell everyone to at least boil the water if they don't want to buy distilled. Just boil the water and have some sterile water on hand for your experiments. Yeah, and so not everything was laid out, explicitly. That's one thing I could talk about a little bit more, is that, we had to modify the protocols, given that if you're familiar with like using other educational provider kits, like there's like Biorad, for instance, they have a lot of rigor in their protocols and all the background material and everything like that. It's pretty thorough in the instructions. Not so much with these kits. There's some gaps in there you have to fill in. So we were doing that over the summer. All right, and then the other thing we did is that we, in the all online remote world, we recognize the need to have electronic record keeping, and that is obviously a trend in the industry. So it finally gave me the push to adopt an ELN, electronic laboratory notebook. I've been wanting to do this forever. I kind of tinkered with different ones over the years. So over the summer, we tested 3 ELNs. We tested SciNote, Lab Archives, and Benchling. There's others out there, but those are the ones that look the most interesting. And we settled on Lab Archives. I'm happy to show that to you later if anyone's interested, but I've just got a picture there on the right. One of the reasons being that it was fairly cheap compared to the other ones. It's about $20 per student. We were able to fund that through our grant dollars. And it offered Canvas integration, so that was kind of nice. Benchling is totally free, and I know CCSF in our area and actually Baybeck, they use that and have a lot of success with it. So there's good options out there. But electronic laboratory notebook was really important for us because we really emphasize good documentation practices. That's part of our, any science, right, needs that, right? Whether you're doing research or working in industry, but what we really do take the industry perspective of good documentation practices. And so data integrity and things like that are offered through electronic laboratory notebook. That's something we can talk about now because that's obviously a big trend in industry as they move toward ELNs more and more. So you'll see on the left here, I didn't mention this, but all the material for the kit that we used is on a Google Classroom. So what we did is we took all that material. Students still had access to that through the Google Classroom, but we moved it over to Lab Archives and added our notes that we, things that we learned over the summer in testing the kit to make the protocols more clear. So yeah, that's part of what we did over the summer. Okay, so, oops. I'm gonna let this video kind of run in the background, I think, while I talk about this, but I'll talk about some of the lessons from our summer tests. I don't know if the video will actually, it's buffering here. This is actually Jenny in her home kitchen. She's doing a transformation right now for the GFP experiment. So while that's running, I'll just talk about some of the lessons that we learned. Well, these two students are ringers. They've done a lot of laboratory already. So everything worked perfectly for them. There were a couple bumps in the road I can talk about with some of the experiments, but they had very few issues because they were already very experienced. So that's one of the shortcomings of our summer tests, was that we didn't have someone who was brand new, but that was kind of the point too. But anyway, so a couple issues working in the home that came up. Look at the area she's working in. She's in her kitchen. We had to write in some safety and cleaning protocols that weren't in the materials that we had. that tell people like, make a 1 to 10 dilution of bleach so you have that on hand to clean up spills. When you're disposing of a plate, put some bleach over the agar so it kills the bacteria before disposing of it. And then, always, she's wearing a lab coat. We didn't give students lab coat, but we provided eyewear and gloves. So always wear those. One other thing that came up around experimentation, Jenny, her partner, was surprised at how stinky E. coli was. And Jenny knew that very well, but, like she had to have a conversation with her partner about the E. coli that was out on the kitchen counter. And then I think she ended up moving into a cabinet or something, but yeah, the smells that you're going to have is E. coli doesn't have the best of smells. And there's another experiment where you're doing a biosensor using light. It's the P-Dusk, P-Dawn biosensor experiment. You need to have a light on 24 hours. And that was another thing, why is the light on 24? So I had a conversation early on with students about this semester, about having, whoever they live with, their loved ones, people they're living with, friends, whoever it is, have a conversation with them about what they're doing. Also have a plan around keeping the material safe and out of the hands of anyone that might get into it, especially like younger kids, right? Keep it out of, we provided them, you'll see in a second, a banker's box to contain everything fit in there. So I recommend just, making sure everything's back in that box, keep it high up, especially if you have any young children around. But everything in the kit, and I'll show you the inventory, it's all safe stuff. There's some antibiotics in there. So, I think I've had one student in all of my teaching years that's had an ampicillin allergy, right? And that's just with the powder. But yeah, the bacteria is, K12 and all that. So here she is plating it. Yeah. So, and then you see there on the right-hand side, we'll go over these experiments later on, but these are the roughly 6 experiments, I've kind of boiled them down a little bit, that the kit provides in the 8 weeks of curriculum, okay? So we don't need to watch the whole thing, we'll move on from here. There we go, make sure, yeah. Okay, creating the kits. All right, so the Odin, like any vendor, sells kits to make a profit. We look to make it as cheap as possible. So we used a mix of our own equipment and consumables like plasticware and then their perishables. We could have made it even cheaper than what's listed here if we had had time or enough access to lab where we could have grown up our own stocks and prepped our own plasmids and things like that. We just didn't have time with everything else that was going on and our limited access to lab. But the entire cost per student is about, $9,500. We had to buy some digital scales for weighing out agar and antibiotic. These 2-digit digital scales are like anywhere from $8 to $10 on Amazon. And we paid, and the ELN is mentioned there too, $20 for the electronic laboratory notebook. We used the California State grant called Strong Workforce to pay for that. The most expensive piece of equipment that we loaned out to students was micropipettes. So each student gets 3 micropipettes. And so we had a sign up form. We had, like I said, I waited till students, we passed the last day to drop without a refund just to make sure enrollments were settled down and I wouldn't be giving out kits to someone who decided they don't want to take the course and have a hard time getting a hold of them. So it's yet to be seen. We're going to be collecting the kits back in, I think, 2 weeks so we can replenish them and switch them out with a new kit. I don't anticipate any problems, but there is at least, one student that's been less active in the class. So we'll see. I hope we can get a hold of them. We'll do everything we can to get that stuff back. That is one of the worries when I first thought about this is, will we get everything back? That's precious equipment to us, but yeah, so I can report back to you all later about that if you're curious. So yeah, there's Paul, my TA, who Jenny got a job at Bolt Threads, so I was sad to see her go, but Bolt Threads, they make spider silk. They're the spider silk synthetic bio company, so she's super happy there. I'm sure having done this over the summer didn't hurt her chances for applying for a job, right? What are you doing during the lockdown? Well, I'm doing synthetic biology from my home. How does that sound? I think that sounds pretty good. So there you can see the stack of boxes there in the back. That's each kit, how we packaged it for students. And this is a picture of what's in the box. The only thing that's missing is the scale, which, I have that linked on the inventory. You can pull that up on Amazon. But you can see a lot of this stuff is just common things that we have in our laboratories anyway, like all the plasticware I had, so I didn't need to buy new ones. I went ahead with filter tips because for the micropipette, the aerosol tips, because I don't know about you all, but when people are brand new to micropipetting, I like to use those just to make sure there's some barrier to pulling liquid up into the mechanism of the pipette. So since I wasn't going to be with students personally when they were doing their micropipetting for the first time, I hope that, the aerosol tips will prevent some damage, potential damage to my micropipettes. What else can I say? A UV light. We had to buy a UV light for the GFP experiments. Those were, I think, $8 each on Amazon. And yeah, you can see it's pretty common stuff. And then the next picture is of the perishables from the Odin. So all these are like plasmids, transformation solutions, things like that. They do a lot of lyophilized bacteria, so pretty stable that way too. The only thing that we made was we went ahead with one of the experiments, the early experiments with bioluminescence. So we made a starter plate for them, so we didn't have to buy. It saved a little money on the on our reagent purchase from the Odin by making a starter plate from an existing stock we had of the bioluminescent bacteria. That's PJE202 there on the left. Okay, so I already kind of mentioned this, but getting students to campus, right? We had to work within guidelines and safety protocols that were already established. So making sure that students didn't overlap in the room and we didn't get like a line out the door of students coming in to get their kits. We had just a sign-up procedure for them to come in and pick up their kit individually. And so there's one of my students picking up his kit. That was about 6 weeks ago now, I think. Okay, let's get into some of the lab material now. So weeks 1 and 2 is kind of like how I start my class anyway. We learn the basics of, well, we start off with a lot of lab math too in the beginning, and we did some of that as well online through Zoom, but we start off with using micropipettes and scales and other common laboratory equipment. So we have a weekly check-in with this class. It's our gateway class. I didn't even tell you, but our gateway class to our program is called Bio 75. And that's the class that I decided to use the kit for because I feel like the intro students would benefit the most from a lot of hands-on. So anyway, here's me doing a pipetting demonstration at my home for students live on Zoom. And there's one of my students, Omar, following along and pipetting. So the first experiment is, again, much how we start the semester with learning basic equipment, how to pipette and things like that. So. Also during that first 2 weeks, they learn how to pour agar plates in sterile technique, meaning many people do the kind of environmental sampling lab where they touch their fingers, gloved and ungloved, to agar plates and things like that. That's what that picture is on the right. And then pouring agar plates, I demoed that as well on Zoom before they did it, but there's one of my students, Ryan, pouring in his lab at his home, pouring some plates. And it was amazing to see how few there's nothing that much different about, I would think, about a home versus our lab. Our lab's in a chemistry department. It's incredibly dirty. So I think, it's just down to the operator and how careful they are. We had very few contaminations. And as long as you're using somewhat sterile water that's been boiled or distilled or something like that, then you're okay. So they were pouring plates and learning about sterile or aseptic technique in weeks 1 and 2. I noticed, I didn't want to keep rambling on here. I noticed there's some questions in the chat. So I don't know, I haven't looked at it, but if
Yeah, so Doug, mostly it's just been people sharing information, but
Okay.
there is one question that just came in asking if you could offer some clarification around what you sourced from Odin
Mm,
versus what you had included in the kits from your lab.
okay. Sure. Let me go back. Um, so this picture shows all the consumables that so everything in this picture, except if you can see where I'm circling right here, where you can see these labeled items that have that's the Odin's label. All of those things these are from the Odin. Everything else is us. So we had a lot of like gloves. We have tons of gloves. We have tons of agar petri dishes, 100 millimeter petri dishes. I had to order some of the I like the visitor glasses from VWR that they're just great because they fit generally over people's glasses pretty well. So we bought a case of those so there was some expense here, right, that I didn't incorporate in the cost I mentioned before, because I consider this almost like operating costs for our general lab. So I didn't boil it into the cost of the kit. But yeah, like filter tips, Eppendorf tubes, conical tubes of various sizes, 50 and 15 mil, tube racks, inoculating loops, L-shaped spreaders, weigh boats, sterile toothpicks. We autoclave for them. We put in some Sharpies for them, program literature, that's just our own program, some kit instructions that I'd written up separately. This sheet here is Artel's 10 tips for pipetting. We love Artel, love doing their pipetting challenge. Nick Cap at Skyline, if he's here, he's got an Artel PCS. It's a pipette calibration system. We share that across the bay. But anyway, when I posted it to social media, they love seeing that. They're like, "Oh, you put in the 10 tips, great." But anyway, so that it's just these things here that we bought from the Odin. I think we gave them a box for organizing. That's what this is. Just organizing all their tubes. It's like a paper, like a freezer box for Eppendorf tubes. And by the way, this link here, I'll show you what it points to. This is the entire inventory for each box. And so I linked here, like I said, the scale that we purchased. We actually bought it through the Odin because we have a hard time ordering directly from the Amazon. It's like you have to go out of pocket and get reimbursed. And there's all these limitations on the dollar amount, total dollar amount and everything. So we just bought it through the Odin. And yeah, it's got the breakdown of Odin versus stuff that we provided. So this will be in the slides, and I assume we'll share them later. But yeah, this link will be there, so you can look at the full inventory.
Hey, Doug.
Yeah.
The link that you have for that inventory is not available to everyone. Could you change the sharing permissions on
sure.
that so we could all see it?
Sorry about
Thanks.
that. Anyone with the link? I must have, maybe I put in the wrong one, because it says anyone with the link. So I'm not sure why it did that. Let me try this in the chat and see if this helps.
Yeah, why don't you just copy that link and drop it in the chat? And then...
Yeah, I used Bitly. I shortened it with Bitly, and maybe Bitly messed things up. I'm not sure, but try that one in the chat and see.
That one works. Thank you.
Okay, great. You're welcome.
And then, Doug, there was another question about the pipette tips. Wondering if those were sterile when you put those in the kit.
Oh yeah, that's true. They were. We bought them fresh from the supplier, and sorry, my screen, I can't get out of full screen. There we go. We bought them directly from the supplier, and they came pre-sterilized. So I don't know if maybe you're asking because they're bagged, right? So Paul did that. He bagged them in Ziplocs. It's close enough, right? Because we're talking bacteria here, not cell culture. So yeah, these are sterile tips in the bag. See if I can get, yeah, okay. All right, so we were, okay, now we can go on to week 3, 4. I'm just gonna walk through like the different sections of the lab so you can know what it all looked like. So weeks 3 and 4 are bioluminescence, plate streaking and making solutions. So that picture on the left looks really beautiful. That was taken by my TA over the summer. her partner had a traditional like shutter stop camera, I guess is what you call it, right? The one where you can open up the aperture and just collect a lot of light, like you do night photography or astrophotography and stuff. So that's how people always take pictures of bioluminescence. If you look at it in real life, it's more like this, where you can just barely, I don't know if you can see that on your screen. I can just barely see any glowing. This is someone really struggling to get it showing at all. And if you're in a pitch black room, you can see it. I mean, you can see it, but our phone cameras don't pick it up. There may be an app, we were looking for apps that might help with like combining photos and stuff over time to get it almost like a time lapse so it can collect more light, but it is difficult to photograph. So this was a summer result. This is a current result from my students. Most of them got it to come in. Some of them had to redo it. But yeah, that's the bioluminescence experiment. This is not a transformation. The transformation's in the following week or following section, but they just get the cells, they plate them out, and there's some material in the curriculum about how the bioluminescence works. There's links to papers and things like that. And then they also learn plate streaking in this experiment. So these are some plates that have been streaked out. You know, they're learning. It's not the best dilution streak I've seen for sure. But that's kind of the point, right? We're trying to get this material out there so they can at least do something and we can provide feedback. So this is the PJ 202, which is the bioluminescence experiment streaked out. And then it seems a little out of place, but the reason why they don't, making solutions, they make a stock ampicillin solution. The one kind of fascinating thing about the kit is that in order to make the bioluminescence plate, the ampicillin, the Odin provides LB agar with ampicillin already in it. And it works. I've never done that before because we know that, you know, boiling ampicillin is going to deactivate a good amount of it, but it still seems to work just fine. So then because they set it up that way, they do teaching about making antibiotic stocks after the bioluminescence experiment has been done, which seems, you know, to me, it's a little backward. I wouldn't have done it that way myself if I were designing it, but that's how it's set up. So I didn't want to totally reinvent things this go around, but that might be one area that things could be improved in terms of the flow and how the information is delivered. So these are all, like, keep in mind, all these pictures are in my students' homes, like they're doing this in their home, which I think is really cool. And there's going to be some really, I'll show you later on some ways that students came up with some very innovative ways to solve problems like incubation and how to create a sterile environment. So, okay, week 5, 6. This is GFP and biosensors. A lot of us do GFP. This is actually a transformation. This is my student, Ryan. He's got I just love how he set up his home lab. He's got like a, kind of like, you know, those lab diapers on the bench. I don't know what material that is, but it looks like our kind of lab diaper or bench diaper for picking up spills. He's got tubs that organize all of his different components. He's got everything laid out really nicely. I mean, this to me is a beautiful setup. And he's doing his transformation right now. The transformation is like any other ones that we do, a very simple one, but it's just going to deliver the GFP plasmid. And this is the plasmid they use is it's a constitutive producer, so you don't need induction. Kind of nice. It takes out a step of having to worry about induction, but it's fine to use whatever strain you want. But yeah, so that's the GFP lab. Here's some results. These are actual results from home. Okay, looks beautiful. Actually, some of these look better than what I get in lab sometimes with the Biorad kit. Biorad does a great job, but sometimes I have trouble with it. They have great quality control. Never say anything bad about Biorad, but I have had a couple semesters where it doesn't look this pretty for sure. So those are some nice GFP results. And then the biosensor lab. This is a really cool, this gives more to synthetic bio, right? Because synthetic bio is about creating organisms that act as machines. And so a biosensor in this case is sensing light through the PDUSK, PDON plasmid system. So I don't know if you could tell, but the PDUSK there in the left, that one on the bottom, that's actually has started producing the RFP. So that's what it's making it's turning on a gene that will activate production of red fluorescent protein. the P-Dawn didn't work out. This was a summer result, and I'm still getting results in, like I said, this is where we are right now in my class currently. So I haven't gotten all the results in for my students. So this is actually a summer result. We had this one's kind of confusing because they didn't understand why, even over the summer, they didn't understand why you had to keep P-Dusk in complete darkness throughout the entire experiment. Otherwise it wouldn't work. And P-Dawn in 100 light all the time. You could actually, turn on the P-Dawn after it's been in dark, but especially for the P-Dusk, I think this was like try 2 for my TA, right? That he actually messed it up, had trouble with it, I should say, the first time around, and then got a decent result the second time, at least for P-Dusk. But yeah, there's also information on how the system works, and this paper is linked in the curriculum, which I don't know if many of you use Sci-Hub, but there's ways to get these out of for anyone to download. But yeah. Okay, and then the last week of the curriculum, like I said, there's 8 weeks of curriculum in this kit. It's a CRISPR experiment, and it's a very simple one. It's probably not as exciting as the out of the blue with Biorad, but again, it's done in the home setting, and it's pretty easy to do. So what the CRISPR experiment does for this lab is to introduce or create streptomycin resistance in the E. coli. So this is a successful experiment from the summer, again, because we actually haven't done this in class yet, of the E. coli. Each colony there represents a successful CRISPR experiment. One thing I could mention here is that, and I'm going to get to this, I'm jumping ahead, but these are all incubated at room temperature. Some students decided to do, and I'll show you some examples, make their own incubators, but you notice in the equipment that there was no incubator given to them, not even a heating pad, because I actually didn't want to buy them at the time. And it turns out I'm going to buy them anyway for the next kit, but I didn't want to because it said, hey, you can do it at room temp. And we had success over the summer running it at room temp. So I said, okay, we'll do it. It adds on about 3 or 4 days to the experiment though. So when I'm saying each of these experiments is like week 7 and 8, it's because it can take 3, 4, 5 days sometimes before colonies start to show up. But the good news is they work. It just takes longer. Okay, so let's talk about some of the innovative solutions that students came up with. I really got excited seeing this as we progress through the past few weeks. So on the left here, this is they already had a seed, that's like a seed heating mat for like seedlings, if you're propagating in the home and you want to keep your seedlings warm. And that mat has a thermostat attached to it, so you can adjust the temperature. So he was able to create in this cardboard igloo cooler an incubator that got kind of close to like 37, right? It wasn't great, but I think there it's reading kind of low because he had it open. But that was he could turn around his experiments in it like the typical turnaround time, like a day, right? So he played it the next day, it's ready to go. And this one, I think, in the middle was probably the coolest I had not thought of. One of my students, Erica, figured out a way to turn her oven on the lowest setting possible. And she verified that it was a good temperature by putting in a thermocouple there, that temperature probe, which is, I don't know what that is for or from, but it's a pretty interesting looking thermometer. So she was able to accelerate her experiments and keep it on a normal timeline by using her oven. And that was the first student that I was like, wow, that's brilliant, because, oven's going to be pretty common for a lot of homes. So yeah, that was kind of cool. Another one that was really interesting was this one. I just got this sent to me by a student this past week. She was wanting to create a more contained environment for her experiments. And I don't know if she already had this, but it's a pop-up greenhouse that you can buy on Amazon. And she was using this as her hood. And that's her pipetting right there. I think it's a cool picture. I like that. So I thought that was really neat. I didn't, ask them to do this, and I certainly commend them for doing it. I didn't want them to spend anything out of pocket to do any of this, but some of them were so inclined to do so. So great, that's fantastic. I see there's some questions coming in, so maybe I should pause. Or at least comments. I see the chat.
Some comments about other things you can do, and Ying Su's saying that a small yogurt maker can
Yes.
work well
Yeah.
too, and you can get them for about $30. So it's a low
That's right.
cost
Yeah,
option.
I bought a yogurt maker, and I asked students if no one's taken it home yet, but I need to try that out more. Yeah.
Oh, and Sandy's suggesting maybe an Instapot would.
Yes, that's right. Someone, yeah, Instapot. Yes. Sous vide. Yeah, there's a lot of. Yeah, I didn't. That's one area where I would have doing this again. I would have come up with an incubating solution for them, because with the need to actually redo some experiments, some students were needing to redo it because they had some issue come up and they weren't getting results, and I wanted people to have the opportunity to redo it. It would actually be much more feasible if we were incubating, because then they could turn it around quicker.
So while you're talking about equipment, Doug, how do you heat shock for transformations?
Yeah, that's a good question. There is a heat shock step, and I think I'm trying to remember. I'd have to look at the protocol to answer that question exactly. But because I don't, yeah, they have a target temperature you're supposed to get to, and I forget how. Good question. There is a heat shock step though. Yeah. So I think what I would do is I'd just boil some water, and I'd have a thermometer on hand to check it, to make sure it's at the right temp. We didn't actually provide thermometers for them, so I don't know when we think if there was a way to. Yeah, I'll have to get back to you on that, because I have to read through on the ELN. I had that experiment was like just last week, and I'd have to look and see if students had an interesting way to figure that out. But you got me there. I don't exactly know how they executed it. Okay, so I'm kind of winding down here, maybe a little early, but that's fine. So the 8 weeks of curriculum is coming to an end. In about 2 weeks, they'll return their kits. And so I decided to continue with a different kit from the Odin that's on human cell culture. And so this past week, we got a test kit from the Odin, drove down to their headquarters, which is a house in West Oakland near MacArthur BART, and picked up HEK 293s in the media and the plasmid, because actually it does a transfection during this lab, to test it out to see if it works. So in order for this one to work, we needed to invest in some more equipment. So we bought 18 inverted scopes from Amscope. That's the model number, or SKU is LN. I think it's an L, not an I. LN50. It's this, I'll show you a picture of it in a second, but it's a really tiny inverted scope. It's about, they gave us a 10% discount. So I think after the discount, it's about $55 a piece. With cell culture, HEKs and other mammalian cells need 37 degrees. So we are purchasing the heating mats with the thermometer, so they can just keep their flask on the heating mat. The Odin didn't have a non-equipment version of it. So I actually asked them, what can we get it without the equipment? Because we can get it cheaper ourselves. And so the perishables themselves are $99 a student. So it's roughly 170 a student. There's 4 weeks of curriculum. You don't need CO2 incubation, I hope, right? We're finding out. But this kit's actually been out for a while. And if you're curious about finding out like how, let's say, the community of users is doing with it, there's a Facebook group called the Odin School. And people post about their experiences with the kit, and their, if troubleshooting comes up, then somebody jumps in, like, Josiah Zahner jumps in, or somebody that's experienced with the kit and answers questions and stuff. But so cell culture is something we actually don't do a whole lot of in our lab, because we have 2 biological safety cabinets, and that's a limitation. It's a bottleneck when we're in lab. But if this is successful, then we perhaps don't need to use this biological safety. I'm still, all my training in me screams, this is not possible, right? You need CO2 incubation. You need to have a biological safety cabinet. There's no way this is possible. So we're testing it out, right? I'll let you know how it goes. But here's a picture of Paul, my student. So these are the materials. It comes with a flask of pretty decent density HEKs, and in a lot of media. And then here's your L15 with 10% FBS. Notice they just loaded up on antibiotics, right? That's the it's a lot of antibiotic. And then here's the other reagents you get for the $100. And then here's some early results. These just started coming in. Paul is at his home there. There's Paul in his home. Here's the scope, the cute little inverted microscope. You can actually get a camera attachment for it or not. The camera is, I think, about another $75. I opted not to get it, but the camera would be kind of cool if you can. We have a lot of Surfaces, Microsoft Surface tablets in our department. I thought about, having the Surfaces go out with the students, but we don't have that many for all our programs to have them. So that's a limitation. But yeah, you can easily use it without the camera or with. And there's free software you can download online. But you can see, here's the cells. They're there. They came unattached because they just seeded the flask, and then it took about 24 hours for them to attach. Now they're attached to the treated plastic of the flask, and we're going to be testing these out over the next couple. Well, we're kind of accelerated timeline. We're trying to test it out as much as we can before we do it, so we know any bugs or tricks or anything like that. But all I can say about the kit is that it's mainly involving teaching them how to grow the cells aseptically, in the home, right? Kind of contradiction, but right, with tissue culture. But and then it does culminate with a transfection using a plasmid that gives them resistance to an antibiotic. And so they do a 12-well plate assay doing different concentrations of antibiotic to verify there's a control, right, showing that it kills them. And then there's the plate that, like an MTS or types, right? Some of you have done those tissue culture tests where you've got your 12 wells and you're increasing the concentration of the antibiotic to see how much resistance has been conferred. So that's the next step. When the other kits, the kits they're working on come back, we will restock them. They'll go to the other class, and then the new kit, which involves the scope and those materials you saw, will go out to the class that had the first kit. So it's going to be a kind of a little bit of a choreography to get that done, but that's going to happen in about 2 weeks for us. I'm almost at the end here. So yeah, we are. So great. Are there any more questions?
Yeah, we did have a question in the chat about student risk. And if you had to have them sign any waivers to participate in the home labs, or if you had to include any additional curriculum around sterilization.
Right. Well, I mentioned, so one of the things that we did at the very beginning of the semester is talk about safety precautions and sterilization or neutralization of your biologics, your cells and things like that. So we covered that. Now, as far as approaching, you said asking them for kind of like a waiver. No, we didn't do that. I let my deans know that I was doing this. They got very excited. They were like, wow, what a cool, innovative way to deliver content. Now, maybe if they'd been explained more about exactly what was happening, they might have started to get anxious, but they don't know biology, like many deans, right? So I told them what I'm doing. They said, great. I'm putting stuff on social media. They're liking it, and it's getting, our programs out there, right? That we're still in business, right? We're still moving. Enrollments are down a lot for all of us, I'm sure, right? So we're trying to recruit students. We're trying to attract people in. I'm trying to show people that Laney College Biomanufacturing is in business, and you can come and learn, lockdown or not.
Well, we invite you to, ask Doug any additional questions at this point. Feel free to unmute yourself, show us your, show your camera if you want to. I'm just putting into chat that, we will be posting the recording on the website. And we also ask that you complete a short survey of the webinar. And I've put the link for you to complete that as well. So that really helps us. We're funded by the National Science Foundation, so we need to have survey data to be able to show that we're meeting our goals as the national center.
This is great, Doug. Thank you so much for doing this.
Oh, you're welcome. Thank you.
I mean, I love that your students are so creative. And
Yeah.
I kind of think that in many ways, they might be understanding a lot more of what they're doing because they have to solve problems to do it.
Very true. Very true. Yeah. And in lab, I don't, things work really well in my lab, right? We have everything we need. I've done it so many times. When things don't work out, we generally don't have time to go back and redo things because we're just so tightly, on our schedule. But having the opportunity for students to go back and redo things is kind of nice because they want to. I mean, and I don't know, there's probably different feelings on that for people out there, but I like the ability for them to make mistakes and then try again.
Do they get to have like group discussions?
Yeah, so well, that's a good point. We use Canvas, and I for this class, to be honest, I haven't done many group discussions, but they communicate through Canvas. Like I don't have a discussion assignments. That would be a great thing for me to add on in the future, is to have kind of timed with each activity a discussion point for them to collaborate on and things like that. That's one aspect that I haven't put in yet, is more collaboration.
Okay, yeah. They're definitely doing a lot of independent problem solving and doing it in creative ways.
No, that's going to be great material for them on interviews.
Yeah, I think so.
I'm wondering too, are they, I'm wondering if any of them would be interested in blogging. We're always interested in having students blog at InnovATEBIO, and they don't have to do it forever or a long time commitment, but we can pay them a little bit to write one blog and just show how they solved a problem with some photos. Our people would eat that up.
Oh yeah, okay.
How I built my own incubator.
Yeah, and in fact, I should point out to everybody listening, if you didn't, I don't know if you saw the last newsletter, but we do have a couple blogs from a student at Miracosta College writing about what it's like. She said she felt like a real scientist when she had DNA samples in her freezer between her bacon and something else. I don't know. And also from Merritt College, they've been sending microscopes home too.
Oh yeah. Yeah, there's some really cool things going on out there. And I feel, like I looked at what Miracosta's doing, and they sent out 3,000 kits to their student. I was like, oh my gosh, now that's, that kind of budget. Ooh, that sounds good, yeah.
People who are into the quantified self movement and like to do a lot of, measurements of their microbiome, you can only imagine what's in their freezer.
No, I don't want to imagine what's in their freezer. But I know they do have a lot of glucose blood tests.
One asking about, you mentioned that you were able to obtain equipment for less than what Odin could provide to you. Do you have the resources for where you got that equipment?
Yeah, so what I'll do, I didn't put links for everything there, but like the heat mat, which is optional for the kit that I was explaining today, but it's required for the human cell culture kit. That one is sold for like, I want to say $20 on Amazon. And I just got the quote from the Odin actually undercut. They were like 15 each. I don't know how we got a better deal through the Odin than on Amazon. But with the scales for sure, that one we were able to cut a few dollars off. The UV lights too. So just finding things on Amazon, and I'll put more of those links on the inventory so you can find them. And the scope was the biggest one. The microscope for the last kit I just explained, that one, if you bought the full kit from the Odin, it's like one kit is like, I think $599 because it comes with all the equipment, the micropipettes, the scope, the camera, everything. So it's a very expensive kit. But if you break it down to its components, you get rid of the camera, it became affordable because we got a $55 scope directly from, it was United Scope in Irvine, California is where we got them from, United Scope.
Great. And then we also had a question about prereqs to participate in this class.
Yeah, we don't have any prereqs. Our classes have always been that way to make it a stackable certificate program. The only class that we have that has prereqs is in our second year of the AS degree program. There's a capstone class that requires one of our previous courses. But yeah, our certificate has a chem component. It has a math component. We have micro as a part of our certificate, not a prereq, but yeah, so we've had very low to no prereqs in our program.
I just put a question into the chat. Thanks, Doug. This was really great. Here's though a concern that I'm having, and you know, I wouldn't stop doing this, but it's an important concern, I think. Especially now, the students learn you don't need a lab to do that stuff. You can do it at your own kitchen. The real smart ones could see that before, but it's one thing they're learning. I hope this comes through as an audio okay, because I have an echo here, although I'm only in logged once. So I'm coming back to this. Think human cells, Drosophila cells, or plant cell culture, right? So there's just small jumps. Think GFP as opposed to the toxin, the gene that encodes the toxin protein in jellyfish. And then, you know, you can make strawberries that are like nettle plants or houseflies that evolve the toxin. And when they land on your skin, that's really not fun to have, right? It's like touching a jellyfish. So the question is like, do you guys see a space for, or do already, bioethics consideration in this kind of teaching? Because we're really empowering people to do that stuff at home and tinkering, and that's fine as long as they, especially if they come through our guidance to that kind of stuff, as opposed to some you know, terrorist background.
Yeah, right. No, we do. So not in this course, but in other classes in our certificate program, we have a bioethics component in our intro to biomanufacturing course, as well as our scientific communication course. But discussing bioethics, I mean, that's always, in this class, if it comes up, we definitely get into it. It hasn't come up so far. But yeah, that is certainly a concern. You started your question with a different idea, and I can't remember what it was, but it was about, I think, a safety question. But yeah, anyway, it's okay.
Well, mine was more the super creative use in generating human killing houseflies.
Oh yeah, that's right. Yeah.
We have another question that came in from the chat, and that's, do you have students participate in competency and skill checks?
Yeah, that's another great question. So right now, the ELN is the way I'm checking. So I could show you what a typical entry looks like for a student. I don't think it's too much to, actually, you know what I could do? I could show you the TAs. That way I'm not, he's an employee. That way I guess I'm not violating anything. Give me a second while to answer your question, I don't have any skill checks or I would love to in the future. Like I normally do like a pipetting demonstration in the lab practical where they have to demonstrate that they use the pipette correctly while I'm watching. And then there's another one in that first exam where they do a load of gel, right? They load a gel electrophoresis agar-agarose gel, and they have to do that while I'm watching so I can see their technique. For this, I haven't incorporated that yet. I have colleagues that do conferences, you know, almost weekly check-ins with their students. I'm always impressed to hear when people do that. I would love to be able to do that, like to have more interaction individually with my students. That would be one way to do it, would be to make a competency or skill check, and I would love to do that in the future. If you want, I could show you like a typical lab notebook entry. So I know they're doing it because I require them to put in pictures of themselves doing it. So here is a picture of, this is my TA doing it, but he's showing that he's setting up, pouring the plates. This is just the plate pouring one, making the agar plates, showing me how he's using the equipment and things like that. This one doesn't have the results in it. I think it's in a different picture, but then they'll show a picture of them with the plates, and I can require, I didn't ask them on this one, but I could say, okay, take a picture out of the plates after they've been at room temp for like 3 or 4 days or something too, so I could see if there's any contamination. I didn't require that on this one, but you could add those things in, sure.
There's probably a few of them that could film themselves doing
Yeah,
things too, or have a
that's true.
friend with an iPhone or a whatever
That's right.
camera.
That's right.
Then you can start to use the good ones for your demos.
Yeah, that's right. Yeah, yeah.
TikTok biotech.
That's right. Yeah, actually, that would be a great, if I were to do a competency thing, I think what would be kind of cool, now that you gave me that idea, Sandra, is to say, okay, you got to post your skill check on TikTok, and that's how I'm going to evaluate it. Because we generate a lot of social media views that way, you know, like.
That's, yeah. It's,
And
I
make
had
sure they
students
use,
turn in TikToks in the springtime.
That's great.
They had to explain viral life cycles and stuff, and it actually worked well.
That's awesome.
hey, they could use the Laney biomanufacturing logo too. So you build recognition for your program at the same time.
That's right.
I love it.
that's why these meetings are so good.
Yeah. All the ideas. No, it's great. Yeah. Yeah.
That's neat, Aaron.
Yeah, it worked out. They actually asked me, they were like, can we use TikTok to do this? And I was like, sure.
What is
Whatever
it?
you want to do. I've been using Flipgrid too for like skills if they had to show me stuff at home. So that worked well.
What is it?
Flipgrid, you basically can create a topic. So a lot of times I use it as like an introduce yourself to the group. So you make a topic that says introduce yourself, and then you as the instructor can set the video to be anywhere from 15 seconds to 10 minutes. And so you can kind of like, if it's an intro video of yourself, I just make it like 2 or 3 minutes long. But then you could also have it set up like if you want your students to do a presentation, they could record themselves for 10 minutes and they have to fit their whole presentation into that window. It also allows for screen recording. The students can comment back and forth to each other, and then you as the instructor can also give like video feedback to them.
Mhm.
So it's a cool website. It's called Flipgrid, Flipgrid.
Neat.
Doug, do you think so I teach at a high school. I'm here right now.
Oh, nice.
Do you think that, unfortunately, we're able to meet in person with our students? I guess a lot of the times when I've talked to other high school students, there's a big concern for safety with high school students doing things at home.
Mhm,
And
mhm.
so I want to try some of the stuff, but I also am like, I don't want to send it home.
Yeah, right. That's a good point. I mean, I remember you probably know the Biorad folks, right? Like Damon Ty, who all of us know, right? I remember telling me when they introduced that algae bead kit, the first thing that happened in a high school classroom is the kids started eating them, right? It's like, eat the algae beads, right? So, yeah. No, I get it, yeah.
I've only had a kid eat an agarose gel once. That was fun.
Okay.
Yeah, that was a good time. It was just a plain gel, so they were safe, but I let them think they were dying for a little bit.
Okay.
But yeah, I used the Odin CRISPR kit one time, and it did work well, but I did it in lab.
Oh, okay. Yeah, great. Yeah. I mean, one complaint, just on a side note on that, one issue with it is it lacks proper controls, the CRISPR kit. So I always think like if people do end up adopting it more, like there's opportunity for us to help improve the quality of these kits to make them a little more, standard for us, because there's some issues like that where there's not proper controls on certain experiments and things like that. So probably to save costs, because I don't think it's that he didn't know they were supposed to be there. It's, with CRISPR, you have to design more expensive oligos to do the control, but yeah.
Well, he's doing self-experimentation without controls, so
That's true, yeah.
What control would you
But
use?
it's kind of that disruptive mindset, get it out there, and then the feedback will improve it. So
right.
So you're absolutely right to share back, right?
Yeah, that's right. Yeah.
Neat.
Great. Well, thank you so much, Doug. This was a great session. As a reminder, we do have 2 more sessions, webinars this fall. The next one is going to be, I think, November 20th. It's the 3rd Friday. It's kind of our pattern here. And we have some folks talking about how they're actually adapting the entire biotech curriculum to be online. So it's an ATE project, and that should be a really good one. And then our last fall session is going to be in December, the third Friday again. And that is going to be a mix of PIs from ATE projects talking about their work and how they're contributing to the broader community. So definitely keep an eye out for those. We'll be sending out information via the newsletter and our social media channels. So yeah, thank you all for coming, and you have a great weekend.
Thank you.
Thank you.
Thanks.
Thank you. That was great.